Hello viewers, welcome again to my common algorithm series. In this video, we shall look at linear search algorithm. To begin with, what is a linear search algorithm? This algorithm searches for a specific value in a set of data by checking each item, starting with the first item and continuing until it either finds the item or it checks the last value. This type of algorithm is usually applied to one-dimensional arrays. For example, given that an data array contains the values 1, 5, 6, and 8, write a linear search algorithm in pseudocode to search for the number 6. Our solution includes a variable table which specifies the names of the variables we are going to be using and their descriptions. The algorithm is very simple. We start by assigning the length of data array, which is the size of the array, to the array size variable. And we loop through, starting from when the index is 0 all the way to when it gets to the last index of the array. Now, we are using array size -1 to specify the last index of the array. Recall that in this case we have 1, 2, 3, 4 elements, and length as a function simply extracts the number of elements that are contained in the given array. Having done that, it will not be within scope to get up to the index which does not exist, because arrays are 0 index, meaning that the first element of this array begins with 0, the second one 1, the third 2, and the last is 3. In other words, in a given array which has, in this case, 4 elements, the most significant index or the highest index value is 3, which is gotten by subtracting 1 from the size of the array. And that's exactly what we're doing here. Now, if the data array in the existing array index, maybe in index 0, is equal to 6, then we output 6 found 6 at index concatenated with array index. So what this ampersand is doing is to actually concatenate the string found 6 at index with the actual index which is contained in index value. So if, for instance, the index value which points to where the 6 is located in the array is 0, then you are going to see a 0 here. If it is 2, you are going to see a 2 here. So in that case, the output is simply going to read found 6 at index 2. Now disregarding this, this is just a kind of way to concatenate or join this string with this number. We end if and move forward to the next index. When you look at the trace table for dry running this, we are going to simply perceive this in this manner. We have at the 0 index, the data contained therein is 1. Since it is not equal to 6, there will be no output. As 1 index, 5, there shouldn't be any output. At the second index, we have found 6. Then we are going to read found 6 at index 2 as our output. Remember this 2 I told you about with regards to this concatenation operator. So, Having mentioned that, notice that the search continues even after the value 6 has been found. So we still have to search for this even when we have found the 6. Although this solution solves the problem, it's rather inefficient. It can only be deemed to be efficient when we are searching for all the values in the array that match our search value. However, our second solution stops as soon as a match is found. Let's look at the second solution. We've introduced in this solution the found variable, which is going to store a Boolean constant. So we initialize it to false, and we also initialize our index to 0 since our index is going to start from 0. Remember that arrays are 0 indexed. While found is equal to false, that means as long as found is false, do the following. Check whether the value contained in the array is equal to 6. If it is, then generate an output and reassign the value of found to true. Else, simply increment the index by 1 and end if. Now this is actually pointing to the fact of the matter, and in this case, as soon as the found has changed from false to true, the loop automatically stops, because the condition for the loop body to be executed is only when the found is false. Then it can continue to be executed. Looking at this, let's run the code. At the first index, found is false because we've not found it, right? And of course, data array is 1. At the 1 index, false, we've not found it. When we have true, when we have the second one, we have found this, then found is true. Okay, and the output is going to be generated. Let's also run using 1568, and we are going to search for 7. Now, remember our search value here is 6, but we have decided to search for 7. What happens when we are searching for 7? Let's look at it. When we are on the first index, we can't find 7 because we have 1. The second index, which is 1, we cannot find 7 because we have 5. The next one is 6. We have not found 7. The next one is 8. We have not found 7. The next one is 5. That's the index, is 5. And still, we don't have anything. Of course, at this point, we have actually exhausted what we have from 1 to 8 in this case. So we are actually running out of bound, out of range in our index counting. So what this suggests is that our algorithm at this point is erroneous. Now, searching for a value that is not contained in the given array leads to infinite loop, and the array index will exceed the highest boundary. So what this simply means is that when we use this solution, it's going to lead us to infinite loop, alright? Because especially when the value is accidentally not contained in the array you are searching it in. So we are not going to solve this using that particular algorithm. Let's look at the algorithm that is more reliable to us. We have seen found, it still remains the same, and array index remains the same, array size remains the same also, but we've introduced yet another thing. While found is false, an array index is less than array size. Do the following. Then we perform the same operations we performed, alright? And we now check if found is equal to false, then output not found. Alright? So this is an addition to what we have to output. Okay? And at this point now, we have all it takes to run our program. Look critically at this trace table, and you will be able to understand what exactly is going on. Thanks for watching for now, and I hope you pay very close attention to these tutorials, because they try to make sense when you can watch them over and over again, and try to work out things on your own. Should you not understand anything, please do not hesitate to write me a comment using the comment box. All the best.